Going to work some problems to review for the Chapter 5 test. So we have P of t equals 500 times 1.17 to the t, and Q of t equals 250 e to the negative 0.04 t. So for both P and Q, can we first find the annual growth rate? So let's see, I'm going to say for P, the annual growth rate, that one is just the 1 plus r is equal to 1.17. So that's going to be 17%. For the Q of t, this will be a little more involved. We want the e to the negative 0.04 to equal 1 plus r. Let me make that r a little more clear. And if we plug into our calculator, e to the negative 0.04, then that looks like 0.96079. So if we subtract the 1 from that and then make that into a percent, that means we're going to get a negative 3.921%. For the continuous growth rate, now we're going to, with the first one, the P, now we want this 1.17 to equal e to some power. So we're going to take the natural log of both sides, and that's going to give us the value of k. So the natural log of 1.17 is 0.15700. So we can say that that's going to be 15.7% continuous rate. And for the Q, then we can say we want the continuous growth rate is just going to be a negative 4%. That one's pretty straightforward. The next problem, the population is 3,500 at time 0, and if it decreases by 150 per year, that means that it's linear. And so we're going to have that 3,500 minus 150t. For the second one, it's decreasing by the 3.5% per year. So this is going to be then the 3,500, this is going to be exponential growth. So it'll be the 1 minus 0.035 or to the t, or if you like, we can make that 3,500 times, I think that'll be, what is 1 minus 0.035 is 0.965 to the t. And if it's decreasing by 2% continuously, then that's going to be our Euler's number E. So 3,500 E and to do the decrease, it's a negative 0.02t. Okay, if Starbucks prices increase by 7% per year over 5 years, by what percent do they increase? So if they're increasing by 7% per year, that makes that 1.07 raised to the 5th, and we want to know what percent, what value of r is that over that 5-year period. So I'm taking 1.07 raised to the 5th, and that looks like 1.40255. And so that means that the percent is going to be 40.255% over that 5 years. Okay, let me slide this up a little bit. Okay, now if the inflation rate in Bolivia is 0.71% per day, what is the annual inflation rate? Now remember, this is not an annual rate that we have to divide by 365. That is our daily increase. And to do it in a full year means we're going to take it to the 365, and that's going to be our 1 plus r. So I'm going to go 1.0071 raised to the 365. That looks like 13.228 is equal to 1 plus r. So 12.228 is the r. Make that into a percent, and that's like, yikes. It's going to be 1,000, about 222.8% annual inflation. Whew. The next one on the graph, which is 3 to the x and which is e to the x. Remember, e is like about 2.7, so the 3 is a bigger base than Euler's number, so that means it's going to be steeper to the right and hug the x-axis quicker to the left, so that's going to make this 3 to the x be our f of x, and that means the e to the x is going to be the g of x. And on the next one, so for a logarithm, same kind of idea. Logarithm base Euler's number is base e. That's 2.7. It's bigger than 2, so it's going to hug the x-axis quicker and the y-axis quicker. That's going to make it be the blue one. And the 2 to the x is a little smaller. That's going to make it be k of x. We're going to invest $20,000 and we'd like to have $25,000 in 8 years. What does that make the effective annual yield? So we're going to have $25,000. We're starting with the 20,000. We don't know what that r is. That's what we're trying to find. And that's going to be raised to the 8th power. So we'll divide by the 20,000. And so we can cancel the 3 zeros. 25 over 20 is, I think, 5/4 is going to be 1 plus r to the 8th. So on our calculator, we can raise that to the 1/8 power. So the 1.25 raised to the 1 divided by 8 power, it looks like 1.02829 is 1 plus r. So subtracting off the 1 and making it to a percent, looks like it's going to be 2.829%. Okay, let me slide this up if I can. So if we have a population of 300,000 decreases by 12% year, what is that continuous rate? So the 300,000 doesn't really much matter. If it's decreasing by 12%, that's going to be 1 minus 0.12, and we want to know what's the equivalent continuous rate. So that means we have 0.88 is equal to e to the k, which means we're going to have to take the natural log of 0.88 in order to find k. So the natural log of 0.88 is negative 0.12783, and so that's going to be a negative 12.783% continuous rate of interest. Okay, now we have a curve, this yellow curve, and we also have a blue straight line. So they go through the points 5, 2, and 13, comma 9. To get the equation of the line, we need to find the slope. So we can take the 9 minus 2 over 13 minus 5. That looks like 7 and 7/8. 7/8 it is. Then we can take either one we want. So I'm going to start with the the smaller number point, the 5, 2. So it's y minus 2 equals 7/8 times x minus 5. And it didn't tell us we had to be in slope-intercept. So let's call that good. Now the exponential is going to be a little trickier. We're going to use y equals ab to the x. So we're going to get 2 is equal to ab to the 5th. And we'll get 9 is equal to ab to the 13th. So I'm going to take the bigger exponent divided by the smaller one. So that's going to give us 9 divided by 2. The a's will divide out. We're going to get b, and then the 13 minus 5 is to the 8th power. So we're going to take that 9 halves, I'm going to call it 4.5, and raise that to the 1/8 power to get our b. So 4.5 raised to the 1 divided by 8, and I'm getting 1.207 to 3 decimal places. But I'm not going to use the rounded answer to solve for a. I'm going to come back here, and to solve for a, we're going to take 2 divided by our b, that 1.207 to the 5th, but I'm going to use the best accuracy our calculator's got. So 2 divided by, I'm going to go up arrow and capture that 1.206845, blah, blah, blah. Raise it to the 5th and hit enter. And that looks like it's going to be a 0.781 to 3 decimal places, which is going to make our exponential equation be a y equals 0.781 times 1.207 to the x power. All right. Now the next one, to solve this one, we're going to have to put y1 in as x plus 3 and y2 in as 6 to the x, and then find the point of intersection. I'm going to pause this and then come back with the answer. So the two answers I got were x equals 0.736 and x equals negative 2.995. So the graph looked something like there was an exponential coming up pretty steeply, and there was a straight line coming through something like that. And we found those 2 points of intersection. Okay, I think this is the last one. 32% of a substance decays in 55 years. What is its half-life? This is actually two problems here. So if 32% decays, that means we have 68% of what we started with. And it doesn't really matter how you want to do this, if you want to do it with e to the k, or if you want to do it with a 1 plus r to the t, it doesn't much matter. Maybe I'll go with e to the k, which we don't know, and that's going to be in 55. But you don't have to use it with Euler's number. Either way is okay. The p is going to divide out, and so then what we're going to do is take the natural log of both sides, and the natural log of e to the 55k is going to be just 55k. So our k is going to be the natural log of 0.68 over the 55. So when we do that, the natural log of 0.68 and divide by 55. Oops, I got the... Let me try that over again. It's the natural log of 0.68 divided by 55. And that's like a negative 0.007, and then it goes on and on and on. I'll just call it that for now. Now we're coming back to our equation, which was now a. We still don't know what we started with. Now we know what the k is, the negative 0.007t. Half-life means when will there be half as much, and so I'm going to call that a 0.5, or actually, because I like a chance to use our properties of logarithms, I'm going to call it a 1/2, but you can do it either way. So we can divide off the p's. It doesn't really much matter how much we start with. Then we can take the natural log on both sides. At least I will, because of this Euler's number e in our exponential. Now, this is what I was hoping for. We can show our properties of logarithms on many fronts. The natural log of 1 is 0, so we get natural log of 2. We'll divide by the negative 0.007 to get our t. And so I'm going to capture that exact value. So I have negative natural log of 2 divided by, I'm going to up arrow and capture that negative 0.00701204551. And we're going to get 98.851. 98.851 years, I believe, is going to be our half-life. Okay, very good.